Okay, so our second conic section that we're going to look at, we looked at circles in the last video, now we're going to look at parabolas. You're familiar with parabolas, you should be. Integrated Math 2 did a ton of work on parabolas. We spent an entire first semester on that. But really the definition we really didn't focus in on. We kind of looked at quadratics and we looked at equations, but we didn't go as in-depth as we will here. The definition, the set of all points equidistant from a fixed point that we call a focus, and a fixed line, we call that the directrix. So I know you know what a parabola looks like. I'm going to draw a quick sketch. So standard parabola, here's your x-axis and your y-axis. And so a parabola looks something like that, right? Now let's do that in a different color. Let's go blue. And so there's our parabola. Now, according to the definition, a parabola is the set of all points that is equidistant from something, from a point called a focus, which I'm just going to randomly put this dot here because it's just a random drawing. So that's going to be our focus, that's our fixed point, and a fixed line called the directrix. Now the directrix for our standard parabolas is always going to be either horizontal or vertical. For a parabola like this that opens upward or downward, the directrix will be a horizontal line. We will look at parabolas that open right or left, and those parabolas, the directrix, our green line here, would be vertical. Now, according to the definition, what it says is if we grab any point on the parabola, if I grab this point right here, the distance from that point to our focus, and it doesn't look like it in the picture because I didn't measure anything, is exactly the same as this distance here. Obviously, they don't look the same because I didn't draw this to scale, I didn't measure anything out, but these two distances have to be the same for our parabola. That's the idea behind this. If we had a sideways parabola, just simply take your computer screen, turn it on the side, and you'll see exactly what I mean there with a sideways parabola. Don't do that, you'll break your computer. So, standard form, we have a standard equation for circles, and now we have a standard form for parabolas. This form is going to be possibly different than what you saw in Integrated Math 2. I know my Math 2 students never looked at this formula. I'm not sure if you did or didn't, but either way, we're going to assume that you didn't. So here's the standard form. There's going to be two equations here. We only had one equation for a circle, because a circle, no matter how you look at it, it's a circle. But with a parabola, our parabolas are either going to open up and down, or they'll open left and right, and that'll give us two different equations. So this is for an up-down parabola. The usual ones that you've looked at in the past. The equation is going to be x minus h squared. We're seeing some commonalities based on what we saw with circles in the last video, equals 4p. We'll talk about that p in a second, times y minus k. If we have a parabola that doesn't open up and down, if we have a parabola that opens right and left, right or left, it can't open both right and left, but if we have a parabola that opens right or left, the standard equation is similar but not exactly the same. It's going to be y minus k, because k always goes with y squared, equals 4p times x minus h. So just notice that when we flip the parabola from up and down to left and right, the parentheses basically trade positions. So, what do these things mean? Well, in both equations, they mean the same thing, which is kind of nice. The vertex of our parabola, that's that bottom or top point, or the right or left point, we know what the vertex is. Just like with the circle, the center of the circle was hk, the vertex is also hk. Just like we saw in the last video, h and k are going to be opposite because they say y minus k and x minus h. So when we have the equation, we're going to grab the opposite value of that. Then we have this p. One thing that has to be true, p cannot equal 0. If p equals 0, that's bad news. You don't have a parabola then, because x minus h would simply equal 0, and that's not going, x minus h squared would simply equal 0, and that's not going to be the case. So p is not going to equal 0. What p is the distance. And it could be either horizontal or vertical distance. Parabolas can be slanted. We're not going to look at anything slanted. P is the distance from the vertex to the focus. It also is the distance from the vertex to the directrix as well. But when we measure from a point to a line, sometimes we don't measure perfectly, and it's easier just to measure from point to point. So that is what we have there, and now we'll take a look and see how we can use that. Okay, so bouncing over to the next slide, what I want to do is just want to show you how all of this works before we get to an example of writing things out. So I've got the equation here, x plus 1 squared equals negative 4 times y minus 1. We have to figure out whether the parabola is going to open up and down or left and right. It's easy to figure out. It's what is being squared. If x is being squared, it opens up and down. If y is being squared, it opens left to right. Since x is being squared, this is going to be your normal looking parabola. Let's get the vertex, because that's pretty easy. The vertex of my parabola is given to me in the equation. We just do the opposite of the value. So since it says x plus 1, the x-coordinate of my vertex is negative 1. Since it says y minus 1, the y-coordinate of my vertex will be positive 1. So I'm going to go ahead and plot that on my graph. I'll go with blue again. So negative 1, 1 is my vertex, and so that's going to put the vertex right there. Cool. Check. We could do a lot of other things. We're going to look at this equation specifically. We need to find p. I know that in front of the parentheses is 4p, and that's a negative 4. And so if we do some quick math, we can see that p is negative 1. So what that tells us is that the focus and the directrix are 1 away from our vertex. P specifically, as I defined on the last slide, and we can take a look at that again, P is the distance from the vertex to the focus. Very important. It happens to be the same distance to the directrix, but we want to think of it as the distance just to the focus. And so when we see that P is negative 1, that tells us that from our vertex we need to go down 1 to put the focus. And so that red dot right there, and I'm going to put a little F by it, that's our focus. The directrix happens to be the same distance away, but it's going to be in the opposite direction. So the directrix is going to be 1 up. But the directrix is a line, so I can't just put a dot there and go, cool, there I am, I'm good to go. You need to draw a line there. And it's going to be a horizontal line because it's x minus h squared. If it were y minus k squared, it'd be a vertical line. So there's a horizontal line. That's the directrix. To help draw our parabola, the only way to draw the parabola is to utilize things that we've done before. We could plug in values and draw the parabola out. If I plug in, say, 0 into the parabola, if I plug in negative 1 into the parabola, I can get the y values and I can draw up what that parabola looks like. That's not super duper important. We don't have to worry about being exact. I'm going to go ahead and try and be exact as I can. If I plug in x equals 0, I'm going to end up getting 2 values. I'll get when I plug in y equals 0, I get x equals 1 and x equals negative 3. And so my parabola actually looks something like this. As we said, the definition is that the distance on this parabola is the distance from the focus to the parabola is the same as the distance from the directrix to the parabola. So if I grab, say, this dot right here, this distance to the focus is exactly the same as that distance to the directrix, and that distance needs to be a perpendicular distance all the time. So that's how it looks like. That's how P works. That's all we're going to do with it. We're not going to graph parabolas except for using our calculator to graph parabolas or things like that. So you don't have to worry about trying to graph it based on this form. If we needed to, we would just plug in values. But that's how P works, and that's how we can see our parabola. Next, I want to show you how to put it into standard form. So let's go ahead and take a look at another slide for that. All right, so on this last slide here, write in standard form y squared plus 6y plus 13 equals 4x. So we know how that formula is going to look. It's either going to be x minus h squared equals 4p times y minus k, or flipped around. How do we know which it is? Well, look at what's squared. Since this says y squared, then I know the formula that I want is the general formula with y. I want this to look like y minus k squared equals 4p times x minus h. That's the goal. That's what we're trying to set up. Now, as far as that 4p is concerned, that can be any number. That could be a 17. It just means that p would be 17/4, right? So we're not necessarily going to have a 4 there. Don't get hung up on that. It might be a 4. It might be something else. Don't get hung up on needing a multiple of 4. It could be any number there. So we're going to do basically the same thing that we did with circles. I'm going to try and get this to be a completed square. To do so, I don't want that 13 there. And so I'm going to go ahead and get rid of that. I want y's on one side and x's and numbers on the other. If this were x squared, then I'd want x's on one side and y's and number on the other. So I'm going to go ahead and subtract that 13 from both sides right away. That's going to leave me with y squared plus 6y. I'm going to go ahead and leave some space. If you watch the video on circles, you'll know why I'm leaving that space. Equals 4x minus 13. We need to complete the square. I'm not going to go through that process again. If you don't know that process, go back and watch the circle video and you'll see that. We're going to take half of 6, which is 3, and square it, which is 9. And so we're going to go ahead and add 9 to both sides. Why do we do that? That allows us to factor the right side, the left side. Y squared plus 6y plus 9 definitely factors into the quantity y plus 3 squared. That's the whole idea of completing the square. On the other side, I'm just going to combine my like terms. Negative 3 plus 9 is negative 4. Now this is working out nicely. It doesn't have to work out this way, but we only have one more step to do. If you'll notice, 4x minus 4, those are both divisible by 4, so I can factor that 4 on out. And so we end up with y plus 3 squared equals 4 times x minus 1. We now have this thing in standard form. If we wanted to get any information, I know that the vertex is going to be h comma k. H is always with x. Don't go the order of the way it's written. H is always with x. So h is going to be positive 1, opposite of negative 1. K is going to be negative 3, opposite of positive 3. We could find p if we wanted to. I know 4p has got to be the number in front of the parentheses, and that's 4. So that would tell us that p is equal to 1. It doesn't have to work out nicely. The next example we see it won't. But there is your vertex. There's your p, and there's the equation. All right, so like magic, I put one more equation up here. Let's put this one in standard form as well. This one has x squared, and so it's going to be an up and down parabola. I'm going to go ahead and get all my x's together on one side. They already are, 2x squared and 8x. I'm going to get rid of everything that's not an x to the other side, and that's going to be the 10y. I'll add it to the other side, as well as the 7 I'll add to the other side as well. Now notice I left a space because I am going to complete the square. But I can't complete the square right now because of that 2. That 2 is bad. When we complete the square, it needs to be a perfect square. Typically, we want to just be x squared. So what I'm going to do first is I'm going to divide everything by 2. So that way I'll just have an x squared. Now whatever else happens, happens. So that becomes a 4x. On the other side, I'm dividing everything. Don't forget to divide everything. That's a 5y. Then 7 divided by 2, I'm just going to leave it as 7/2. I prefer fractions over decimals because decimals aren't perfect. If that were, say, 2/7, it wouldn't be exact. I always want things to be exact. Next, I'm going to complete the square. I'm going to go through the process by figuring out what I need to add. If I take 4 and divide it by 2, that's 2, and 2 squared is 4, so I'm going to add 4 to both sides. Why do I do that? That allows me to factor the left side. X squared plus 4x plus 4 will totally factor, and that factors down into the quantity x plus 2 squared. On the other side, I'm just simply going to put together my like terms. So I have a 5y. I have to add together the 7/2 plus 4, getting a common denominator. That would work out to be 15/2. Now, I'm almost done. The left side's good. It's just the right side. On the right side, we need it to be 4p times parenthesis y plus or minus something. Now, the 4 doesn't matter. We just need a number in front. So I need to have in the parentheses just a y. So what am I going to factor out? I'm going to factor out a 5. Now, this fraction here, you can factor anything out of any number at all. So on the left side here, we're not going to change x plus 2 squared. On the right side, I'm factoring out a 5. So I have a 5 here, and all you're going to do is just divide. So 5y divided by 5, well, that's just a y. 15 over 2, when we divide that by 5, 15 over 2 divided by 5 is 3 over 2. And so then this just becomes plus 3 over 2. And now we have our equation. If we want to list out the information, our vertex is going to be negative 2, comma 3/2. If we wanted to find p, we totally could. I know that 4 times p would have to equal 5, and so that simply tells me that p is 5/4. That means that the vertex is 5/4 away from the focus. And like magic, there is the assignment. So if you want to try and boost your grade, you need to do these assignments. So page 653, work through those problems. If you have questions, feel free to send me a text via remind. Otherwise, do work on those, and then I will see you again for our next video.